Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring a factoring shortcut that can only be used on perfect square trinomials. So before we get started on what the shortcut is, let's define a perfect square trinomial. Now, a perfect square trinomial is the result of squaring a binomial, and will have one of the following formats. So if you have a squared plus 2ab plus b squared, that is a perfect square trinomial, and its factors are a plus b times the quantity a plus b. Or you could write it as a plus b quantity squared. Another form of a perfect square trinomial is almost identical, except it has a subtraction as the first operation symbol. So it's a squared minus 2ab plus b squared. So the factors of this are a minus b times a minus b, or it can be rewritten as a minus b squared. Now, when you're looking at a trinomial, it's very important that you can tell if it's a perfect square trinomial, because if you can determine that a trinomial is a perfect square trinomial, you will save yourself a lot of time when you're trying to factor it. So, how to determine whether a trinomial is a perfect square trinomial? So, number one, you want to check, are the first term and the last term perfect squares? If they are, list their square roots. If they're not perfect squares, then you'll have to use some other factoring method, all right? Now, in addition to the first term and the last term being perfect squares, the middle term has to be twice the product of the square roots you found in step 1. If the answer to both 1 and 2 is yes, the trinomial is a perfect square trinomial. So, excuse me, in example 1 here, or example A, it says determine whether each trinomial is a perfect square trinomial. So what you want to do is take the square root of the first term. So the square root of 16x squared would be 4x, and then the square root of the last term, that's 3. So they're both perfect squares, so we're good on that. Then you want to check, is the middle term twice the square root of the first term and the square root of the last term? So if I'm going to multiply the square root of the first term times the square root of the last term times 2. So that would be 2 times 4x is 8x. 8x times 3 is 24x. Does that match the middle term? Yes. So this would be a perfect square trinomial because the first term was a perfect square, the last term was a perfect square, and twice the product of the square roots was equal to the middle term. All right. Look at B. We have 25x squared plus 10x plus 4. So the square root of our first term is 5x. The square root of our last term is 2. Now let's check to see if the middle term is twice the first square root times the second square root. So 2 times 5x is 10x. 10x times 2 is 20x. Does that match the middle term? No. So this polynomial would not be a perfect square trinomial. All right, example 1. Determine whether each of the following is a perfect square trinomial. If it is, use the patterns above to factor. If it's not, try to factor it by other methods. If the expression will not factor, then write prime. Now, if the trinomial is a perfect square trinomial, we'll either be using this factoring pattern, a plus b quantity squared, or a minus b quantity squared. So we will determine which one of those to use in just a minute. All right, so let's look at problem A. We have x squared plus 6x plus 9. We need to know, is it a perfect square trinomial? So take the square root of the first term, the square root of the last term, and then multiply them and double them. So 2 times x times 3. So that would be 6x x. So that matches the middle. So now we know we can use one of these patterns, either a plus b quantity squared or a minus b quantity squared. And since this first operation symbol is a plus, that means we'll use the a plus b quantity squared. So take your square root of your first term plus square root of your last term, quantity squared. All right. Problem B, 36x squared minus 12x plus 1. So the square root of our first term is 6x. The square root of our last term is 1. Now we have to check if I multiply those two square roots by 2, will I get the middle term? So 2 times 6x is 12x. 12x times 1 is 12x. So this is a perfect square trinomial. But this time, your operation symbol, your first operation symbol is minus. So I'll take the first square root minus the second square root, quantity squared. All right, problem C, 2x squared plus 15x plus 25. So 2x squared is not a perfect square. So I know this is not a perfect square trinomial, so I have to use some other method. Now I'm going to use the AC method, sometimes known as splitting the middle. If you're not familiar with this lesson, I'll put a link to a lesson on how to use this method, or you can use any other method you've learned. The box method, the guess and check method, whatever you want, okay? In the AC method, you take the value of A, which is 2, and multiply it times the value of C, which is 25. So 2 times 25 is 50. Then you list the factors of 50. 1 times 50, 2 times 25, and 5 times 10. Then you look through that list and see if any of those pair of integers will give us our middle term of 15. Well, right away I notice I can use 5 and 10 because 5 plus 10 is 15. So I'm going to rewrite this trinomial, 2x squared, but I'm going to split the middle term. And I'm going to rewrite 15x as 5x plus 10x. And then the last term stays the same, 25. So all I did was I split that middle term into 5x plus 10x. Then I take out the greatest common factor from each group. So the greatest common factor of the first group was x. The greatest common factor of the second group was 5. So x, 2x squared divided by x is 2x. 5x divided by x is 5. And over here, 10x divided by 5 is 2x. And 25 divided by 5 is 5. You'll know you're doing this right if you get matching binomials. And we did, 2x plus 5. So I write down the outside numbers, the greatest common factors, the x and the 5 go together in a binomial, x plus 5. And then the common binomial goes together, 2x plus 5. So I wasn't able to use my shortcut on that problem because it was not a perfect square trinomial. All right, problem D. We have 9x squared minus 30x plus 25. So the square root of my first term is 3x. The square root of my last term is 5. If I multiply those and double them, will I get 30? So 2 times 3x times 5. That is 30x. So yes, this is a perfect square trinomial, which means I can use my pattern. Now, please notice that your first operation symbol is minus. So I want to take the first square root minus the second square root, quantity squared. So if you notice that your trinomial is a perfect square trinomial, it saves you so much time because you don't have to use the AC method or the guess and check. All right. Problem E, 25x squared plus 80x plus 64. So the square root of my first term is 5x. Square root of my last term is 8. If I multiply those together and double them, will I get 80? So 2 times 5x times 8. 10 times, I do. So that's a perfect square trinomial. So I take the square root of my first term plus the square root of my last term, quantity squared. All right. Problem F, 18x squared minus 15x plus 2. So 18x squared is not a perfect square. So that means I have to use one of my other methods. So again, I'm going to use my AC method. So here the value of AC would be 18 times 2, or 36. So when I list the factors of 36, I'm going to use 1 in 36, 2 times 18, 3 times 12. Now there are more, but I'm going to stop because I'm trying to get 15, so that means I can use 3 and 12 if I make them both negative. So I'm going to rewrite this 18x squared, and I'll split the middle term into minus 3x minus 12x, and then plus 2. Now I'll take out the greatest common factor of the first group, which is 3x, and the greatest common factor of the second group is 2, but because that first term is negative, I need to take out a negative 2. So when I factor out a 3x here, 18x squared divided by 3x is 6x. 3x divided by 3x would be minus 1. Over here, my greatest common factor is negative 2. Negative 12x divided by negative 2 is 6x. 2 divided by negative 2 is minus 1. Again, you'll know you did this right if you get matching binomial factors, and we did. So take your greatest common factors, 3x minus 2, and put them together, and then 6x minus 1. So again, if you don't have a perfect square trinomial, it's going to take you a little bit longer to factor the trinomial. All right, problem 2. Example 2, let's look at trinomials that have more than one variable. These are actually usually a little bit easier, even though they look like they might be harder. So we have 36x squared plus 12xy plus y squared. So square root of my first term, 6x. Square root of the last term is y. Multiply them together and double them. 2 times 6x times y would be, 2 times 6x is 12x, times y would be 12xy. That matches our middle term. That means I can take my first square root plus my second square root, quantity squared. All right, problem B. Take the square root of your first term, 3a. Square root of your last term, 5b. Now check to see if you multiply these together and double them, will you get 30ab? So 2 times 3a times 5b would be 6a times 5b, which should be 30ab. So this is a perfect square trinomial, which means I can take my first square root minus my second square root, quantity squared. All right, I want you to try C and D on your own. All right, welcome back. Let's see how you did. This was 7m. This was 9n. When I multiplied those and doubled them, I got the 126. So my answer is 7m plus 9n, quantity squared. All right. Problem D, the square root of my first term was 3x. The square root of my last term was 11y. If I multiplied those together and doubled them, I do get the 66xy. So 3x minus 11y, quantity squared. All right, last example, example 3. Sometimes you're going to have trinomials that when you first look at them, they do not look like perfect square trinomials. For example, in problem E, we have 2x squared plus 12x plus 18. And you may look at that 2x squared and say, oh, that's not a perfect square. But what if they have a common factor that can be factored out? So I notice that we have a common factor in this problem of 2. Watch what happens when I divide each term by 2. 2x squared divided by 2 gives me x squared. 12x divided by 2 gives me 6x. And 18 divided by 2 gives me 9. Now, what we have left over is a perfect square trinomial. The square root of this is x. The square root of this is 3. If I multiply that and double it, I do get 6x. So I know I can rewrite this perfect square trinomial as x plus 3 quantity squared. All right, look at problem F. 2x squared minus 28x plus 98. So I notice there's a common factor of 2. So let's factor that out. All right, now take your square roots, x and 7. If I multiply x and 7 and double it, will I get 14? Yes. So I know this is a perfect square trinomial. So 2 times the quantity x minus 7 squared. Problem G. 6x squared minus 9x plus 3. We have a greatest common factor of 3. So that would leave me 2x squared minus 3x plus 1. Now, when I look here, 2x squared is not a perfect square. So we have to use some other method. We can't use our shortcut on this problem. So I'll use the AC method. So the AC, 2 times 1 is 2. The factors of 2, the only two factors of 2 are 1 and 2. Could I use that 1 and 2 to get a 3? Yes, if I make them both negative. So I'm going to split my middle term here, 2x squared minus 1x minus 2x. So I just rewrote 3x as negative 1x minus 2x plus 1. I'll take out the greatest common factor from the first group, which would be x. And the greatest common factor of the second group is 1. But because that negative 2x is negative, I want to take out a negative 1. All right, so I'm taking out an x from my first group, which would leave me 2x minus 1. I'm taking out a negative 1 from the second group, which would leave me 2x minus 1. I have matching binomials, so take your greatest common factors, x minus 1, and then write your common binomial. And then put that greatest common factor that we found from the beginning in the front. All right, problem H. We have 4x squared minus 44x plus 100. Our greatest common factor is 4. So let's pull that out. So my greatest common factor of x squared is x. The square root of x squared is x. The square root of 25 is 5. If I multiply those and double them, I do not get an 11. So this is not a perfect square trinomial. If I try the AC method, AC is 25, and the factors of 25 are 1 and 25, and 5 times 5. Neither of those will add up to 11. So that means this problem cannot be factored any further. So this has to be your final answer. There's nothing else you can do with it. And that concludes today's lesson, factoring perfect square trinomials.